Greetings and welcome to my new calculus channel. My name is John Gabriel, and today I'm going to discuss how I first came across the concepts in calculus and how I eventually was led by my genius to discover the new calculus. And it was a long journey, but it was worth it. And so sit back, relax, take it easy. This might be a little bit of a lengthy video, but you're going to learn a lot, trust me. So let's begin. Now, when I was young, I lived in an area that was very poor. In fact, we never had access to a lot of things. We didn't have access to tutors or anything. So the only resource was a set of encyclopedias at the public library, which was really about the size of a small room. And that's where I spent most of my time. So one of the first things I came across in the Britannica when I began to study calculus was the mean value theorem. Okay, so now what it states here is that for any sufficiently smooth sufficiently smooth, that's nonsense, by the way. It's not sufficiently smooth, and continuous is redundant. It's just for any smooth curve, and sufficiently is an adjective that doesn't really belong there because it's either smooth or it's not, and it has to be smooth at every point in a given interval. Okay, so let's see what it states. It says that the mean value theorem deals with a type of average. Actually, to be more precise, it deals with an arithmetic mean, or more accurately, a level magnitude. Okay, so it deals with a level magnitude. What is a level magnitude? Well, arithmetic mean is a misnomer. So if you have a curve like that and you talk about an arithmetic mean, people think that it's something in the middle or that it's something to do with relative position, but it doesn't. And of course, you'll see that it's very easy to debunk that notion of arithmetic mean, because if you take a set of scores of 30 by, let's say, 7, okay, 30 times 7, 1 at 90 and 2 at 100, and you take the arithmetic mean of this, you get 50, which might imply that everybody, did reasonably well. Half passed and half failed, which is totally false because 7 students got grades of 30, so they failed. Anyway, this nonsense aside, what exactly is a level magnitude? So level magnitude is what happens when you take all these lengths, okay, all these lengths, y-ordinates, and you redistribute them so that they're all equal. In other words, so that you can get quadrature, okay? That's what the mean value theorem is about. It's finding quadrature, okay? And you'll see why in a moment. Really, the fact that you have a tangent line at a certain point, which is parallel to another one like that, is unremarkable. Totally, every smooth curve has that property. So let's carry on reading. So it's not a type of average; it's a level magnitude, which is useful for approximations. Actually, it's useful for exact calculations, not approximations, and you'll see why in a moment. And for establishing other theorems, such as the fundamental theorem of calculus. Actually, the mean value theorem and the fundamental theorem of calculus are one and the same theorem. Okay, I revealed that to the stupid morons of humanity. So let me explain that to you. So suppose that you have that y-ordinate there, which is the level magnitude of all of these, right? Of all the ordinates in there. Then you'd write f prime of c. Let that be a, let that be b, or rather let that be x, and let that be x plus h. Then you'd have f of x plus h minus f of x over h, okay? So that is what the mean value theorem says. It says there is a c such that this is true. And it's only true, by the way, if c is not at a point of inflection. Okay, if c is at a point of inflection, it's not true. So the theorem states this identity. So how do we get the fundamental theorem from this? Well, very easy. We simply multiply both sides by h. That's it. That's it. So f of x plus h minus f of x is equal to h times this f prime of c, right? Why? Because somewhere along here, let's say that this is the derivative of this function here, then this length here is like the tangent line, the slope of the tangent line at that point. So this here is equivalent to the area under the curve, okay, which is equal in standard notation to the integral from x to x plus h of f prime of x dx. So as I've shown you now, you get the fundamental theorem of calculus, okay, the fundamental theorem of calculus in one step from the mean value theorem, okay? Nothing there to think about very much. It's all very simple, easy, but none of the prize imbeciles of mainstream academics, math academics, knew this. So the theorem states that the slope of a line connecting any 2 points in a smooth curve is the same as the slope of some line tangent to the curve. Well, that's the unremarkable thing. The remarkable thing is that the arithmetic mean is given by f prime of c, okay? Now, of course, mainstream academics are fools who don't understand what is a tangent line and where it came from and how they even got the concept of tangent line. But of course, a tangent line, as defined by my brilliant ancestors, who were illustrious in every respect, may not cross a curve at the point of tangency. And it doesn't matter whether it's a conic or anything else, because every other curve can be reduced to a set or a combination of conic curves. So it applies to every possible smooth, to every possible function that is smooth over a given interval. Okay. And so again, here, look how they get confused. They say examination of the properties of real numbers and continuous functions actually has nothing to do with real numbers because they don't exist. And continuous functions are not enough. They have to be smooth. So really, what is an arithmetic mean, very briefly? An arithmetic mean is that value, which let's say if you have a set of values, let's make it simple because most of you are quite stupid. So let's say you have a set of values like that. An arithmetic mean is what happens if you make all these equal through redistribution. So it means taking this block here and putting it over here. And now they're all equal. They're all equal. That's what happens under a function. You take all the lengths, okay, and you might say, whoa, Mr. Gabriel, there are infinitely many. I know you morons. And do you think I didn't think about that? I thought about that before you were born. So yes, there are infinitely many or innumerably many, and we get around that by the mean value theorem, which says we can take the difference of the endpoints and we can show that if we sum these up, we have what's called a telescoping sum, okay? Which means that we can perform this super task in a kind of a cheat way, okay? A cheat way, in fact, because we realize that the sum telescopes and we end up getting the arithmetic mean, okay? So let's continue. So when I was young, I first saw this and I continued reading, and then suddenly I arrived at the derivative in mathematics. And boy, my jaw dropped a few times. In fact, I was just astounded at what they came up with. Okay. So, and of course, this is all due to the rot that Newton and Leibniz were working with and didn't understand that the derivative has nothing to do with limits and it doesn't require limits, neither does the integral. And so it ended up being defined like this, okay, as the limit or some incorrigibly stupid mainstream academics prefer an operator, D, which is total BS. Okay. There's no such thing as a differential operator. That's garbage. So anyway, they defined it this way, which is completely flawed for many reasons. And I looked at this and I thought to myself, wow, they had the mean value theorem, okay? Here's the mean value theorem. They knew about it. So they wrote f prime of c. They wrote that, or as I wrote before, f of x plus h minus f of x over h, right? These two are the same thing, okay? Now, why not define the derivative in terms of the mean value theorem? Because here it is. So c is greater than x and is less than x plus h. That's the derivative. As easy and as clear as that. But no, were any of the unworthy, incorrigibly stupid, highly stupid academics of the last 200 years able to see this? Obviously not, because they never understood calculus, and they still don't. So, what I wanted to tell you now is that I was astounded by these things. I mean, I didn't have just one double take. I had a lot of double takes when I read this garbage. And of course, Bishop Berkeley, in his criticism of Newton and Leibniz, was correct. However, if Newton and Leibniz knew what I knew, in other words, if they knew of my historic geometric identity, which I've shown you, before, which says this, and it's realized from the new calculus, by the way, which says this, then they would have realized that if you break this function down using this non-parallel secant slope, you'll end up getting 2x plus h. And this is 2x, and this is h, which is a slope difference. So you can just ignore it. It's effectively or equivalently the same as saying h is equal to 0. So when you're taking the limit, whether you like it or not, by the way, I don't care if you don't like it, you are setting h is equal to 0. It's exactly the same thing. Okay. And is it legal? Well, right. Think about it for a moment. Wait for it. Yes, it's legal. Okay. It's legal to do that. Why is it legal? Because all the terms that have an h in them are in fact the slope difference, which we don't care about. Remember, here you have a tangent line, and here's your secant line, your non-parallel secant line. And so you're looking at the difference between the tangent line and the non-parallel secant line. This q of xh is the difference between the two, right? So we don't care about that difference. All we want is the derivative. And we know from my proof in the historic geometric theorem that the derivative is that expression that does not contain any h in any of its terms. So, and of course, from this, it's much easier to get to your definition of integral, as I showed you in the previous video, okay? So I showed you in the previous video. And if you go and review that, you'll see that to get the definite integral, all you have to do is just multiply by h. That's pretty much it, okay? This here is the arithmetic mean, or rather the level magnitude. Arithmetic mean is a flawed name for it. And of course, if you have your curve there again, and that's the arithmetic mean, then all you have to do is multiply it by the interval width, which is h, and you get the area. And the same thing applies with volumes, okay? The volumes. Same thing applies with hypervolumes. It applies to parametric equations, vectors, gradients, anything else you can think of in calculus works because of the mean value theorem, which is the fundamental theorem of calculus, okay? It took my genius to realize that. Your stupid math professors weren't up to it, okay? Neither were your teachers, but I have revealed it to you. Why is that important? Because when you reject knowledge that is correct and well-formed, you slide further into stupidity. For example, doing things like differential operators, doing the stupid things that you'll typically find in real analysis courses, in set theory courses, topology, which are anti-mathematical rot. So I've given you a little idea now of my journey, how it began. I was I'd say about 9.5 or 10 years old when I first read the Britannica entry. Okay. Didn't understand much then, but it remained in my subconscious, and I went back to it again and again and again, and I studied Newton's interpolation polynomial. Then I eventually got to study De Analysi because they got a copy of the De Analysi in the poor library I was staying at, and I even taught myself enough Latin to be able to understand it. So, yes, that's what you can do when you're a genius. But the nice thing is for you is that I'm sharing these things with you, and the majority of you are incorrigibly stupid. You're not only stupid, you're ignorant, you're hard-headed, you're knuckleheads. I can't say I blame you entirely because your math teachers are baboons, and so are your lecturers. So it's not entirely your fault. But now that I've told you these things, the onus is on you to examine what I'm telling you and to prove these things and to make sure that you stop peddling the drivel that these fools in mainstream academia have been peddling. In other words, you need to do a 180-degree turn, 2 pi radians. Well, actually, it's pi radians, but never mind. So that's what I wanted to talk about, my journey into calculus. And that was just the beginning of things. It took a long time for me to solve the slope and area problem, which Newton and Leibniz were not able to do, by the way. They did not solve the problem. Listen, if you figure out how to do something wrong to get the right results, it still doesn't make the method right. Okay, so yes, they were able to find the derivatives and integrals, but their theory is not the reason that they were able to find it. It's like turning around and saying to me, Gabriel, Riemann was a genius because what he did. Let's get back there again. So Riemann did this. He said, "Oh yeah, we're going to look at rectangular sums." Okay, so Riemann started as follows. He said, take any curve like that and then just divide it into equal partitions. Riemann was an idiot. And then take the limit as the sum goes to infinity. Well, first of all, not only is this incoherent gibberish, because if you do, these rectangles degenerate into lines which have no area. Okay, they degenerate into lines. Turns out that the basic idea of Riemann is an arithmetic mean. So that's why you can do things like numeric integration. Okay, but not because of Riemann. It's because of the mean value theorem that you can do numeric integration. The mean value theorem. Everything leads to the mean value theorem. All roads in calculus lead to MVT, okay? There is nothing in calculus that doesn't lead to an MVT. And guess what? The MVT requires a smooth function, not sufficiently or bullshit like that. What the fuck does sufficiently even mean? I mean, if you had sufficient brains in your mainstream academia, you'd have figured these things out. But you were not up to the task. Now, I think of Jack Hasinger, that Professor Jack Hasinger, that vile reptile who criticized me and refused to apologize publicly. He did send me an email telling me that he'd remove his bullshit, but that wasn't enough, okay? I wanted a public apology. So if you look at Anders Kaesorg, Gabriel. Yes, I'm in Greece, by the way. Gabriel. Um, why do I state that it's bullshit? Well, you can read what this idiot and many other idiots like him, like he, have to say about my ideas. And they're all wrong, and I'm right, okay? So what you have to do is study their bullshit. That's the only way to find out. So let's just say mathematician. That's a better one, I think. Come on. Mathematician. Yeah. So it says, there's some idiot there. So, okay. Where are we now? George Cantor, by the way, was not a mathematician. Anyway, so it says, here's this fine idiot, Jack Hazinger. Mathematicians, well, they're not mathematicians, they're mathematicians. They're not concerned with the objections raised by John Gabriel because every argument he makes that is contrary to established thought has some obvious flaw in it. Well, it seems like Jack Hazinger didn't realize he was railing against the mean value theorem because guess what? The new calculus is is based on the mean value theorem exactly. So he was saying that the mean value theorem has obvious flaws. You moron, piece of shit. Okay, and he put critique in here. By the way, he puts so much critique in here that blackened my name. After that, lackeys and stupid morons who don't know anything about mathematics just felt free to, like this Fred Feinberg, a piece of shit who says, saying that all professional mathematicians have missed something is a tall claim. Well, hey, Feinberg, wherever you are right now, you moron, what do you have to say for yourself? And here's another one. Let's just go back here. It says that they're so smart, that mainstream mathematicians are so smart, which is unbelievable. Anyway, I encourage you to go here and read this whole discussion here, okay? Because it explains how brainwashed, how deluded, how fucking brainwashed every mainstream math academic and their student lackeys are, by the way. And none of them are mathematicians because they haven't accomplished anything that enables them to be called mathematicians. They are, in fact, mathematicians. So I encourage you to read these things, to click like on my videos, to become a member of my channel, my members only channel, and to follow me on academia.edu. So if you have any questions, please feel free to post them on the new calculus YouTube channel and also become a visitor to the new calculus Discord, which is this Discord here. And you'll have access initially to the lobby and questions. And I encourage you to do that, okay? So I'm John Gabriel. Till next time, goodbye.